Moving on with the practice midterm, we'll look at the second half of the problems. So number 11 was another multiplication problem where we're multiplying polynomials. So we're going to distribute the x to all three terms in the second polynomial, and then we're going to distribute the 6 to all three terms in the second polynomial. So when we do that, when we distribute an x and when we multiply by x, we add the exponents. So x times 2x squared, that's like saying 1x times 2x squared. So 1 times 2 is 2. X times x squared is x cubed. Then we're going to take 1x times negative 3x. So 1 times negative 3 is negative 3, and x times x is x squared. Then 1x times negative 2. So 1 times negative 2 is negative 2, and then we have the x to add on. Now we're going to distribute the 6 to those same three terms. So 6 times 2x squared is 12x squared. 6 times negative 3x is negative 18x. And 6 times negative 2 is negative 12. All right, now that we've multiplied everything out, we have 6 terms because we took a trinomial times a binomial. Now we're going to combine like terms. So 2x cubed cannot combine with anything because even though some of the other terms have an x, none of them have an x cubed. So 2x cubed is going to be our leading term. Then we have negative 3x squared. This one can be combined with positive 12x squared. So when we combine them together, negative 3 plus 12 would make positive 9x squared. Negative 2x also has a like term in negative 18x. So together those give us negative 20x. And then negative 12, the constant, it doesn't have a like term, so we just add on a negative 12 on the end. So our final answer is 2x cubed plus 9x squared minus 20x minus 12. Right, so that's multiplying polynomials. Now we're going to factor them. So it's the opposite of multiplying them. Instead of taking polynomials in parentheses and expanding it, now we're going to create factors out of them by taking something that's already expanded and turning them into parentheses. So when there's no leading coefficient, our job is easy. We can go and set up our parentheses. X and x, because x times x is x squared. We're looking for a positive and a negative because there's a minus in the back. So one's positive, one's negative. And we're looking for two numbers that multiply to give us negative 45 and that add to give us negative 4. So if you get stuck, think about all the numbers that multiply to give us negative 45. So we have 1 and negative 45. 2 doesn't come out even. 3 and negative 15. 4 doesn't come out even. 5 and negative 9. And this is exactly what I wanted. 5 plus negative 9 is negative 4. So that's a positive 5 and a negative 9. I can't put positive 9 and negative 5 because if you add positive 9 and negative 5, you would get a positive 4. So this would be our final answer because if you distribute this out like we did on number 11 or number 10, then you'll get what you started with. And that's how you can check your answer. So number 13 is a little bit more challenging than number 12 because there is a leading coefficient. So I say we just get rid of it. And we kind of cheat the system to do that. We take that term and we multiply it by the back. So then we get 2x squared minus 17x plus 16. Oh, sorry. We got rid of the 2. We moved it to the back, so now it's just x squared. So now we're going to set up our parentheses now that there's not a coefficient in front. Plus sign in the back means we need the same signs. They're both going to be negative. Two numbers that multiply to give us 16 and add to 17. That's 1 and 16. 1 times 16 is 16. 1 plus 16 is 17. But we can't forget to divide by what we slide by. So we slid the 2 to the back and multiplied. Now we have to undo that multiplication by dividing by 2. So this becomes x minus 8. And this one, 1/2 does not reduce, so we take that 2 and we move it up front. It's called bottoms up. So we have 2x minus 1 and x minus 8. And again, you can check your work by FOILing that back out or multiplying like we did in 10 and 11, and you should get what you started with. All right, last one for today, last one on this set. Sorry. Number 14, we have x squared minus 81. So this is a difference of squares. We're missing the middle term. If it helps, write in your middle term. So that's x squared plus 0x minus 81. That might help you kind of process what's happening there. So minus in the back means we need one positive and one negative. x and x. Then two numbers that multiply to 81 and add to 0, that's going to be 9 and 9, positive 9 and negative 9. There has to be one positive one and one negative one, or positive 9 and negative 9, because they have to cancel each other out. So one of the biggest mistakes on this one is writing the same sign, like saying x minus 9 squared, but they have to be able to cancel out that middle term. That's why we need a positive set and a negative set. All right, now we're going to be working to find the axis of symmetry in the vertex. For number 15, this equation is written in standard form. That's ax squared plus bx plus c. So your a is 1, your b is negative 6, and your c is 3. When it's written in standard form like that, when you have an a, b, and c, we find the axis of symmetry by taking negative b over 2a. So our b is negative 6, so the opposite of that is positive 6. And 2 times a is going to be 2 times 1. So we have 6 over 2 times 1. And so that's going to be 3. So our axis of symmetry is x equals 3. Now for the vertex. To find the vertex, your vertex is the ordered pair that's on your axis of symmetry. So we know if x equals 3, then the vertex is going to start with a 3. And then we need to find out what y-coordinate goes with that x-coordinate. And to do that, you can make an xy chart, but we really only need to plug in the number 3. And we're going to plug it right in here to see what y is when x is 3. So if I plug in a 3, now we have 3 squared minus 6 times 3 plus 3. So we have 3 squared is 9. I don't know where to write that. 9. 6 times 3 is 18. So we have 9 minus 18 and then plus 3. So 9 minus 18 is negative 9 plus 3, negative 6. So our vertex is 3, negative 6. And our axis of symmetry again was x equals 3. All right, 16 is a little bit easier because this is vertex form, so there is no a, b, and c with vertex form, but it does give you the vertex. Well, there is an a, it's 1/2, but there's not a b or a c. It's just the vertex is h, k. So, minus h plus k. So our vertex is the opposite of what's in here. So since that says minus 5, it's our x is positive 5, and our k is whatever's out here. So negative 2. So our vertex is 5, negative 2. So we like vertex form because we can just look at it and know what our vertex is. And if you know what your vertex is, then you also know what your axis of symmetry is, because your axis of symmetry always goes through your vertex. So if your vertex is 5, negative 2, that means your x is 5, so your axis of symmetry, a of s, is x equals 5. And then you're done. All right, number 17 might have been a tricky one for some of you. I know that you guys know how to find whether it's a maximum or a minimum. So that's by looking at your u. If your u has a lowest point, then it's a minimum. So in this case, we have a minimum. Now, if your u would have been upside down, then your vertex is the highest point, and that's a maximum. But this one, your vertex is the lowest point of the graph, so we say the vertex is a minimum. And then it says, what is the value of that? So your value is your y value. We say y value. So in this case, our value of our minimum is negative 2. It happens at negative 1, but when we want to know what the maximum or minimum value is, we actually want to know the y value. So that's where that comes from. Y equals negative 2. Look at the y, not the x. All right, then number 18 was using the same graph. It wants to know the domain and the range. Domain for quadratics is always going to be all real numbers. You can plug in any number for x that you want to. Your graph goes on and on and on forever. It's going to get really skinny it's going to get really steep at the top, but you can plug in any number for x and get out a y value. So domain, all real numbers, or ARN. Your range, that is going to be different depending on what your parabola looks like. In this case, notice that the parabola stops right there. So your y values never go below negative 2. So what we would say for our range is y the y values. Domain is x, range is y. Y is all the numbers greater than or equal to, because that point is our minimum, -2. Continuing on, number 19 asks us to find the zeros of the function. Zeros, solutions, roots, x-intercepts, they all mean the same thing. So those are the 4 different terms that we use to mean x-intercepts. So if you're looking at the graph, the easiest way to think about a zero is to think about what are the x-intercepts. So in this case, it goes through, our parabola goes through our x-axis at -2, and it goes through at -4. So we would say that there are 2 zeros, 2 roots, 2 solutions, 2 x-intercepts to this parabola. They are x equals -4 and x equals -2. Number 20 is a similar type of problem, but notice this time our parabola never crosses the x-axis. So we would say that this parabola has no real solutions, no real roots, no real zeros, no x-intercepts. So none is your answer here. So in our previous 2 problems, we were solving a quadratic by looking at the graph of the parabola. But for these next 2 examples, we're going to solve a quadratic using 2 other methods. So on number 21, we can use that very first method that we learned about, which was solving for the variable, because b is 0, and so we don't have to factor to solve. What we can do is we can divide both sides by 4 to get the x squared by itself. So x squared equals 25. And then now that our x squared is by itself, to get x by itself, we need to get rid of the squared. To undo a square, we take the square root. So then the squared and the square root cancel each other out. The square root of 25 is 5, but since this is an equation, we actually get 2 solutions. We say that x equals +5 and x equals -5. So remember, if you ever take the square root of a positive number, you can actually get 2 solutions instead of just 1. That means that the parabola is going to cross in 2 places, at -5 and at 5. Right now, on number 22, there is a b, so we can't just solve for x like we did on 21. And the other method we've learned so far for solving a quadratic is by factoring. And it tells you to use it factoring here. So we'll start by ignoring the equal 0, and we're just going to factor this trinomial. There's no coefficient, so we can just jump right on in with our parentheses. Plus sign in the back means same. They're both going to be positive. 2 numbers that multiply to 56 and add to 15. Again, if you get stuck, just start listing all the things that multiply to 56. So that's 1 and 56. That doesn't add to 15. 2 and 28. That doesn't add to 15. 3 and nothing. 3 doesn't work. 4 and 14. That's 18. 5 and 5 doesn't work. 6 doesn't work. But we have 7 and 8, and 7 plus 8 is 15. So we have 7 and 8. Now, the difference between factoring and solving a quadratic by factoring. Before, it would just look like that, and then we would be done. X plus 7 and x plus 8 would be your 2 answers. But if it equals 0, then we have to add on that last step of setting both of them equal to 0. So x plus 7 equals 0, and x plus 8 equals 0. So your 2 solutions then are going to be x equals -7 and x equals -8. And those are your last answers.